So we came back. Let us finish this. Now, the first example we did is just asking us to find the regression equation, just this to find this equation. Next example we do, we ask us to do many things, including testing a hypothesis. Yeah. Hope you can see the screen. Yeah, share this. Now, so the testing hypothesis for regression or the correlation method for testing the significance of the correlation coefficients. There are two methods we use. Either you use the t-test method or the traditional method, or the p-value method. So for the test statistics, we use t equals the r times square root of n minus 2. Since for us, there'll be two variables. So n minus 2, then over 1 minus r squared, with this degree of freedom. So to do that, again, like I said, you use all these formulas to calculate r. The formulas I described at the beginning of the lecture. See either use this one or you use all this one. So, but like I said, I'm not going to take you to that extent. I'm just going to show you how to do it in Excel so that it's on the homework, definitely. And then to be on the exam, just do it on Excel and then type in your answers. Excel will give you the answers right away. You just P them and type it in just the way I typed this one in. So now, let's do this example. Apply it to one example here. It says, the table below shows the mileage and prices of everything here is in thousands of 8 cars in a car mass. So this 21.8 actually means 21,800. 34 actually means 34,000. Same thing with here. 16 actually means 16,000. So I removed the zeros for 3 zeros to make it simple. So I want to bear it in mind when we start, explaining. It says, construct a scatter plot for this data. Calculate the correlation coefficient R. Compute the value of R squared, which is the coefficient of determination. Explain our results. Find the regression equation. What would be the predicted price of a car with 45,000 miles? Is there a relationship between the mileage and car price? Use alpha 0.05. So we have a lot on this one. Now, this question can take you 1.5 hours to finish if you're using an ordinary for formulas. But with Excel, it take you a few minutes. So let's do it. First thing is to put this, the difficult part is to put the data into the spreadsheets, of which we can just do here by copying this. Copy this. We already know that mileage is X and price is Y. So I copy it. And then go to our spreadsheet. What is a spreadsheet? Okay, I'm going to show all of them. Right here. It's right there. So we can put it here. Paste all of them. Paste. The in. So this side is for our left side, and it represents mileage. This one's price. So mileage and price. Excel. How is our Excel? Okay, mileage and price. Mileage. Okay, this is the price, which price is a Y variable, and then variable. Yeah. Now we're ready for work. We call, excuse me, sorry. I'll move this to this side. Now, I'm going to go to data. Make sure everybody's seeing this. So go to data, data analysis. Now choose regression. See regression. Click OK. Okay, doing this, all this. Took us back to okay. This is the one we're doing here. So click on this. For the mileage, if you recall, this is the say input Y range. This is the Y range right here for the price. So the Y range is this here, including the price typed in. And X range is the mileage. Mileage, because mileage we can determine how long we will drive the car. We can control that. We cannot control the price to buy it after we prove it. So that's why this is why it's the X. Labels, and then we have output range. Let's put the output range here. It keeps taking us to the other one. Let's put it under it. Okay. Then we want the residual, we want standard residual, we want the line of speed, that is the scatter plot, so we can know the direction, whether it is positive or negative correlation. So it's very important. So you can now click OK. It gave us everything we want. I'm looking for the plot. I think see, you put the plot at the top of the first one. You can see where you have the plots, mileage. So you can just move it down. Let's just move it down. It's because we did it on. I would recommend that don't do each question in a different workbook, so that it won't be packed up together. Like this one. I'm moving it down to where our question is located. Our question is here, so I'm going to move it down there. Okay. All right. Okay. Now we have our plot already. We can move it by the side. Okay. So now we have everything we need.
Excuse me, Professor.
Yes, ma'am.
Yeah, before you go further, where you are at the regression side, I saw the confidence level at 95%. Does that matter, or is that what's supposed to be in everything we do?
I put it, that one is, we're not looking for confidence level, but in Excel put it, when you use Excel, to give you other information. You give you all the information you need. Then you choose only the one that you need for the question you are answering, you know. So you give us the confidence interval, give us everything. But the ones we need, the only ones we need are those in the question, which include the scatter plots and the R squared, regression equation, and that's all we need. So
okay, thank you.
So let's answer the questions now. The first one says construct the scatter plots. Now, this is a solution. We have a scatter plot already. So what we're gonna do is to go to your Excel and copy the scatter plots we have for this mileage. Click on the line, exactly on the line, then do Control-C, copy it. Then go to the question and paste it. It's right there. See the scatter plot right there. You can, if you like, you can make it big. You know, So you can see the pattern that it is showing. Now, at this point, I can move this to the other side. Now, you can see that it is trending down, showing that as the mileage increase, the price drops. See, at 0 mileage, the price is higher, 15,000. At 100,000 miles, maybe say 95,000 miles, it goes down to about $10,000. You know, so there's scatter interpretation. So it shows a negative correlation. Scatter plot shows a negative linear relationship, because you can see that it is trending down. So negative relationship between x, which is mileage, which is the x variable, between x mileage, which is the x variable, and price, which is the y variable. You can see right here, y variable is the price. So this means that as the mileage increases, price decreases. Any question on that? Okay, good. No question. Good. Excellent. Now,
hello, Professor. Sorry, can you give us the step-by-step of how you work on the Excel?
Ask your question again.
What I'm saying is, can you give us the steps you took to create, to get all the answers on Excel?
That's what I'm doing now. You may have to get it or
on Excel, yeah. What you just did on Excel now, so, so that we don't forget.
You want me to do? I can do it again.
Okay, please. So that I'll take notes.
Let me copy from here. See, are you watching it?
Yeah.
Either you copy it or you type it manually.
Okay.
Copy it. Go to Excel. Now I'm going to do it in because this place, repeating it on this place, it will all cluster together. That might confuse you. So I'm going to take it. So you click on it. See this small box? See small plus sign?
Yeah, a new sheet.
It will give you a new worksheet. So I here, and then I paste it. Okay, they're here now. It's not pasted. Okay. And the left side from here, the left side is the mileage, right side is the price.
Mileage.
So type in mileage and price. What is the Excel right here? Right here? Yeah, that should be. No, that's not the Excel. What is the Excel? Right here. So mileage and price. Yeah.
Okay.
Now next thing to do is to this is your Y variable because you have no control over price, but you can control how much you do, how much mileage you can put in your car. So the ones you cannot control is your Y. The ones you can control is your X variable. So you click on data, data analysis. Okay. Then choose regression.
Okay.
Then click OK. Now you can clean, because I used it before. That's why all these numbers there. So I clean those numbers, the one that I used for the other one. Yeah. So that you can now click. This is your input Y range. So click on that and look for your data. Where's my data at? Okay, right here. This is the Y range. Okay. Oops, excuse me, I missed one. Okay. Then click on that. Then for the X range, click this one. Highlight it. Now, then you check, because I highlighted the names. the mileage, whatever. So you have to check the labels as well.
Okay.
Sometimes interval, they check it by default. If you don't want it, you can just uncheck it. But
Okay.
I give you everything. For the output range, I'm going to use a different output range because I've used it just for the other examples. So that's why it's showing me the one in that example. For the output range, I choose to put it under it here.
Okay.
And click on this. Then this residual, standard residual. Then this line of line of fit plot is important because it will tell you, as you can see, the scatter plot. It tells me whether it is trending down, which is negative, or trending up, which is positive. I checked it. Then click OK to give you everything, including the the line of fit. So that's what I did.
Okay, thank you.
Now I will answer the part A of that question in the handouts. Let's see the part B. Part B says, what is it? Say calculate the correlation coefficient R. Calculate the R. Solution. Have R equals I'm gonna put this is always doing this. I don't know what R equals. It's already calculated. So you go to their Excel and look at our R right there. So make it say this is R right here. 0.757, 0.758. Write it down. So it was already calculated. What's that? 0.758, 0.758. So it is right here. That's your R right there. Okay. Oh, that's not good. Make it right. So 0.758. So you go to your paper and write it down in R is 0.758. Now, Excel doesn't put the negative sign there. So that's why you need this. It tells you that it is trending down, that is a negative relationship. So you gotta make it negative 0.758. Now, at the beginning, I explained this. If you look at this, look at the chart I gave you at the beginning, you can see that it is a strong relationship. See, 0.758 is between here, 0.6 and 0.8. So it's a high moderate relationship. So it shows a strong relationship between mileage and price of a car. So your interpretation now becomes that your the R value of this, as the R value of this, okay, the R value, the R equals this, indicates a strong negative correlation, which means that as the mileage increases, the price of the car decreases. Yep. Question? Yeah, excellent. No question. Very good. As C says, calculate R squared. Okay. The R squared equals R is R. R squared equals. It's already calculated. You go to your Excel. You can see the R square right here. See R squared. So you can see that Excel saves you a lot of time. 0.574 rounded. R square equals to 0.574. Okay. 0.574. You put it on your paper, or you type it in your Alex. 0.574. What does it mean? It means that mileage explain 57.4% increase, or that 57.4% increase in the decrease in the, because it says negative correlation. So the 57.4% of the decrease in the price is explained by the increase in mileage. Interpretation. So an R square, this means that mileage explains, or increase in mileage, and mileage explains 57.4% of the decrease in price. Why only 57.4%? Because there, as the age of the car, but there are other factors. As the car ages, the parts of the car ages, then the car develops problems. So mileage alone does not explain everything, because as we know, there are some cars that have high mileage but still cost more a lot. If the owner is, maintaining the car. After all, antique cars cost even more than even more than new cars. Decrease in price of the car. Yeah. So you can see how this Excel just simplified the whole process. You just get your answers and put them in. Next is to find the regression equation. Solution. Of course, the general model for the regression equation is y equals beta 0 x plus beta 1 x. Beta 1 is the slope, which explains the rate of change, and beta 0 is the intercept. So let's find out the beta 0 and beta 1 here. So that we have the regression equation. So that the regression equation, is here. Now let's go and find beta 0. So how about beta 0? B0 equals B1 equals. So we can update this. Yeah. And this one. Okay. Let's find B1 and B0. I'll write it down. B1, B0, and B1. We go to our spreadsheets that are work in Excel. Look at the handover table. You can see what we have the coefficient. Let me make it. You can see the coefficients. Now this is the coefficient. This one represents the intercept. Intercept right there, and that is mileage is the beta 1. Okay. So that means beta 0 is 17. If you round it, it's going to be 17.100, 17.1, and beta 1, if you round it, it's going to be negative 0.09. It's 0.09. So that the regression equation now becomes what you put the 0 is 17.1 and the 0 is negative 0.09. So that the regression equation now becomes, you put these numbers into this place. So you have y equals 17.1 x. Actually, there's no x on this one. There's no x here. It's only one x for here. This one. 17.1 minus 0.09 x. So that is the regression equation right there.
So is it minus or plus?
If it's minus or plus, is a minus.
You wrote plus, but on the equation there is a plus on it.
There's for your algebra class. See, it's minus 12, right? Now, for your algebra class, you know that if I write it in this form, y equals 17.1 plus negative 0.09 x. So when you open the brackets, right, parentheses, it will now simplify into y equals 17.1. Now, plus times minus is minus. You learned that from your algebra class. X. See? Can you see it now?
Okay.
So now, so what does this mean? It means that, remember, I explained to you that all these are in thousands. I just removed the zeros. So that means that this 0.09, if you multiply by 1,000, you're gonna be about, let me show, 0.09 times 1,000. And it's a negative slope, that means it's decreased. 0.09 times 1,000, what is my calculator?
Do they have this medication now? Do they have Calip's medication now?
Mute yourself, okay? 0.09 times 1,000, $90. So this, so based on this, we mean that the price of a car interpretation the price or the value of the car, okay? The value of the car or the price of the car, the price or value of the car decreases. Why decrease? Because it's a negative slope. Decreases over time at the rate of $90. 1,000 increase in mileage. Question? Any query? Excellent, very good. So let's go to part E. Part E says, what is the predicted price of a car with 45,000 miles? Now remember, again, all these things are in thousands. I just removed the zeros. So here, when they say $45,000, that means you put X equals to 45. Solution. Okay. If let me bring that one down a little bit. So when X, we have 10 minutes left. Okay. For X equals 45, then plug it into the regression equation. I have it in this form. Okay. So using this, using the regression equation. So for X equals 45, Y will be, the price of the car will be 17.1 minus 0.09. So you plug in 45 for X. That gives you the answer. Let me write it down, plug it in. Y equals 17.1 minus 0.09 times 45. So we go to our calculator and then plug the answer and get the answer from there. So you have, okay, 17.1 minus 0.09 times 45. Okay. You know, 13.05. 13.05. That means 13.05. Okay, 13.05. You multiply by 1,000, it's gonna be 13,500. 13,050. So a car with a mileage of $45,000 will cost $13,050. Yeah. Now the last example, maybe say, is there a relationship between the mileage and car? So you state your hypothesis. Solution. Solution. Okay. H2 and H1. H1. We will state the hypothesis. Remember, in correlation coefficient, we are trying to estimate rho. Rho is the Pearson product moment correlation coefficient. And the symbol is given as rho. You can see right here, rho. See? All right. So that's what we're going to test. If there's no relationship between the variable, rho will be 0. Remember I told you when I introduced this, that when the R is 0, that means there's no relationship. So your null hypothesis will now be that rho equals 0, meaning there's no relationship. No relationship between X, which is mileage, and Y, which is the price. Okay. So no relationship between X, relationship between X and Y. So next one is rho not equal to 0. Mean that there's a relationship between X and Y. Rho not equal to 0 means there is a relationship between X and Y. S is the mileage, and so we are using an alpha. So use alpha of 0.05. Well, use alpha. That's why the 95%. Remember, we use 95%. We check 95% on the when we were doing the Excel. Well, I don't even remember that they were asking us to do 95% level. Anyway, in that case, you can see the p-value here. P-value for this relationship mileage. And this you can see right there. Or if you like, I use the critical value. Well, this is the p-value right here. Let me write it down. P-value for the mileage. P-value is 0. It's right here. You can see it right here. P-value, let me color it. 0.09029. Yep, 0.029 is good enough. Now, or if you like, you can use this one significant level. This is the calculated F. This is the you can see that this is the same as this one. Anyway, and like I showed you yesterday, when the p-value is less than alpha, you reject hypothesis. So our p-value equals 0.029. So our decision, let me put this here. Decision. That's where when I put all this. Decision is where we put all this. Okay. So reject, since the p-value is less than this, p-value is less than the alpha, we reject. Reject HO since 0.029 is less than alpha of 0.05. So conclusion would be, since we are rejecting this, you rejected this one. That means this one is correct. Okay. So that our conclusion now will become there is a relationship between X and Y. That means that is, yeah, is a relationship between mileage and price. So ladies and gentlemen, this is the end of our lecture for this semester. Like I said, I'm gonna put the final exam. There's no need to panic. It's something that I showed in the class. What I will ask you questions based on what we thought we covered in the class. So I don't think there's anything to panic about. And finish your homeworks, complete your projects, and upload it for me. And that's it. Any question for me before I leave?
Professor, can you please upload this also along with the video?
Let me save it.
Thank you.
You're welcome. Any other question? Miss Graves, you there?
Yes, I'm here, Professor.
We have less than 1 minute. I want to take the attendance. So what we're gonna do now, please just log back in after 10 minutes just for the attendance. I call your name, you can leave, okay?
Professor, if we have any question, can we send email?
Yeah, of course, you can send me question, but if it's an exam question, I don't answer exam questions.
No, it's not. We might have questions apart from that, some clarification.
Sure.
Okay.
All right, please log back in after this so we can have our attendance, and then Miss Graves and Miss I think I forgot the lady that was speaking to me yesterday, and we were timed out. What her name? Anyway, I can log back after the taking the attendance. I can call. You can ask me, Miss Graves, I think. All right, see you then. What is the log back in after 10 minutes, please?